This simulation shows you what happens when you just have water molecules, and then it shows you what happens when you have a strong acid versus a weak acid. I'm going to leave the strong base and the weak base to you. I'll leave the link underneath, and you can click the link and you can try to see what happens with those. I have a pH meter. So what pH meters do, they actually give a numerical correlation to the amount of H3O plus that's in the water. Right now, it's completely balanced with the OH minus, but this is what you would expect is 1 times 10 to the minus 7th. Notice that the gray waters aren't showing here. I'll make them show. So what you should be seeing is how many waters there are compared to the very few that react with each other and make H3O plus and OH minus. So water on its own just has a very tiny amount of dissociation. You can also see it on this graph right here. So you can see like there's a ton, like 55.6 moles per liter versus the 1 times 10 to the minus 7th. Huge difference right there. Also notice that if we put the pH meter in, or the pH paper in, you're going to be getting neutral, which is what you're going to expect, in either case. And I guess if you want to throw the light bulb in, I'm not really hardly getting any positive or negative, just a tiniest bit of a glow because I have the tiniest bit of H3O plus and OH minus, but not very much. I'm going to jump over to this other one really quick. This other one, what it does is it lets me increase the strength of a weak to a strong. So I want to make sure you know what you're looking at first. So right now, what you're looking at, the gray HAs, that's a weak acid. And weak acids do not break apart into the positives and negatives like the strongs do. But what I can do is, and you can't do this in real life really, but what I can do is I can make that weak acid become stronger and stronger so you can see it breaking apart. So I'm going to just move this over. And so you can see the stronger it is, the more pieces are, it's gaining, what it's doing is the HA is giving the H3O plus an H, and it has leftover A minuses. That's not OH minus, that's A minus. That's whatever was with the acid charge balancing the H plus. So we keep going. So you can see, and also you notice how the pH is going down the stronger the acid it is. So now we're down to stronger, almost completely all the way there, and I've only got one little solvent molecule. You can also tell in concentration, it just increases the number. So if I'm strong in concentration, it just means that there are more in general. You still have that same little ratios, but there's just more in general. That's all the concentration is telling you. So I'm going to jump back to this one, and I'm going to go back to the pH meter, and we're going to look at the strong acid again, and we're going to look at it in the molecule view. So you can see, look, I've still got a lot of solvent in there. So you can tell there's still a lot of water that hasn't reacted with the HA, but more reacted than just water sitting there. And so that is strong. And let me jump to the weak. And also notice the pH is 2. So do you see how many more of those gray HAs are still stuck together that did not dissociate? So this is the equilibrium right there. There's only a certain percentage that will actually break apart. And that will give an H plus to the water when it breaks apart, and making the water H3O plus. And again, that's what I said. That pH meter is measuring that H3O plus in the water. Let's go back to the strong again, the 2.0, and let's throw the electricity in. Do you see how the strong is like a really, really bright light? That's because there's so much positive and negative charges in that solution. If we jump to the weak, notice that it's not as strong as the strong, but we still do have some positives and negatives compared to the water, which had almost none. So there's our strong. Oops, I'm not supposed to show you the strong. You're going to come back and look at the strong. But I also want to show you the graph view. So you can see if I jump between, that's weak. Here's my strong. You can see that the strong has a lot more that's broken apart. It hasn't even finished dissociating either. This is just a strong-ish acid, not one of our, 6 completely strong acids. And then we're going to show the pH. So right here, there's our strong acid pH. I'll go back to the molecule view. So that's the strong acid pH. And then this is the weak acid pH, so you can see the color change.